Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
All right, multiples. You know what multiples are? Because we'll be looking at multiples, factors, prime numbers, lowest common multiples, or what we call lowest common denominator, then highest common factor. So what are multiples? Let's start with multiples.
Okay. Multiples. Multiples of a number are the products of the number and another number.
Yes, the product of the number and another number. Do you know what product means?
Yes, the multiplication.
Exactly. So if we say multiples of a number, we're talking about that number times any number. Let's start, for instance, multiples of 6 will be 6 times.
Multiples of 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24,
and so on. Good. And multiples of 8.
Multiples of 8. 8 times 1, 8. 8 times 2, 16. 8 times 2, 24. 8 times
4, 32, and so on, and so on, and so forth. Now, multiples of 6, like you said, are 6, 12, 18, 24, 30, 36, because if you multiply 6 by something, you get this number. So multiples of a number are the products of the number and another number. Product means times. Simply means times. Okay, multiples of 8 are 8, 16, 24, 32, 40, 48. Now, what are the common multiples of 6 and 8? The ones that are common, that you find in the multiples of 6, and you also find in the multiples of 8, as you can see here.
Yeah.
What are the common ones?
The common ones are 24 and 48.
Yes, because there's 24 in that of 6. There's also 24 in that of 8. You also see 48 in that of 6. And you see 48 in that of 8. If we had continued, we see other ones. Now, which one is the lowest of the common ones? Remember, the common multiples are 24, 48, etc. Which one is the lowest?
The lowest is 24.
The lowest is 24. What we call LCM. Therefore, the LCM of 6 and 8 is what? 24.
The LCM is 24.
You know, there's another way to do that. That's what I tried to explain here, but let's work it out in a different way. There's another way to do it. You can actually write it like this. Are you ready? You write a 6, you write the 8, and then you start dividing both of them. Watch it. Do you know this method? Well, let me even introduce it and see if you know what I'm talking about. We have written the 6, we have written the 8, then we start dividing.
Yeah, I think this is short method.
This method is the shorter method, which is better. So you said start dividing with prime numbers. 2 divided by 6 is 3. Divided by 8 is 4. Whatever you're going to use must divide at least one of them. What can I've used 2. 6 divided by 2 is 3 rather. 8 divided by 2 is 4. Which other number can I use? It's always good to use the lowest one before you start with the higher ones.
So 3.
But I can still use 2. Yes, you can use 3 if you like. That's fine. So long as what you can use can divide at least one of them, that's fine. But why not use 2? 2 can still divide 4. Do you understand?
Yes.
3 divided by 2. If you cannot, what do you do?
If it can divide so if you can divide 3, just put 3 there.
You write the 3
Under,
down.
put 3
Okay.
under.
So 4 divided by 2 will be 2. So at least I can still use 2.
Yeah. Yes.
3
So
divided
that
by
will be
2.
3 2.
3 again
3
2.
1. Sorry.
3 1. So I can now
And
use 3.
Yeah. And
1
that
1.
1 1.
So now the LCM. By the way, lowest common multiple is also called LCM. You know. So the LCM will be you multiply out all these numbers, you know, these numbers, all of them, okay? All of them. So that's what?
That is 2 times 2 times 2 times 2 4. 8 times 3.
So that's LCM.
24.
LCM will be equal to 2 times 2 times 2 times 3. Or you can even say 2 raised to the power 3 times, let me zoom it in so it will come out better. 2 raised to the power 3 times 3, or 8 times 3, which is 24. Is it not the same thing we got?
Yes.
The same thing we got. That's easier. All right. Give me, before we do, you give me those ones you did earlier. Let me see. Let me roll these lines. Remember, whatever number you're going to use must divide at least 1. Let me see something about factors. What are factors?
Factors are things that can be divided together.
That can
Can I say another meaning?
It's fine. Say, divide it in your own.
Okay. Factors are a number that can divide one another.
You have a very great idea. You know, you have a very great idea. The factors of a number can divide a number without a remainder. Isn't it?
Yes.
The factors of a number can divide a number without a remainder.
Sorry, a remainder.
For instance, what are the factors of 10?
And the factors of 10 are 1, 2, 5, and 10.
And 10 itself. Good. 1, 2, 5, and 10 itself. Because all these numbers can divide 10 without a remainder. Factors of a number are usually smaller or equal to that number, while multiples of a number are usually bigger or equal to that number. Okay?
Yes.
What are the factors of 15?
Factors of 15 are 1, 3, 5, and 15.
1, 3, 5, and 15. Always remember 1. 1 is also a factor. And then the number itself. 1 is a factor of every number, or all numbers. Okay, so what are the common factors for 10 and for 15? The ones that are common. Like what you find in 10 and you find in what? Go ahead. What are the common factors? Sorry. Go ahead. What are the common factors?
The common factors are 1 and 5.
Okay, there's 1 in 10. There's 1 in 15. There's 5 for factors of 10. There's also 5 for factors of 15. So the common factors are 1 and 5. And what's the highest common factor?
The highest common factor is 5.
Highest common factor is 5, HCF. All right, you know the other way to do it now.
Yes.
Okay, tell me, you write 10, you write 15, you start dividing. So let's start dividing. Use prime factors to divide. What's the smallest one we can start with?
We can start with 5.
No, there's something smaller than.
Two.
Good. 10 divided by 2.
No, but you can't do 2
Yeah, we can use
because
2.
of 2 cannot divide 15, and
Yeah.
this is highest common factor.
Okay, let me even ask you to use 2 because of something. Because sometimes they may ask you to find both the highest common factor and the lowest common multiple. So let's use any factor that can divide at least 1 so that we'll find all of that at the same time.
Okay, that would be
10 divided by 2.
5.
5. 15 divided by 2, it cannot, isn't it? It can't divide it
Yes.
without the remainder because the factor must have a remainder. So what do? We have to write down the 15 again, isn't it?
Yes.
So what do we do again? Anything that can divide at least one of them.
5.
But let's even say
3.
Okay. 5 divided by 3.
5.
5 because you cannot. 15 divided by 3.
15 divided by 3. 5.
5, okay. So
That'll be 5.
so we now use 5. By the way, you brought down 5 because you couldn't divide, So at this point, we now use 5. 5 divided by 5 is 1. 5 divided by 5 is also 1. You see that? Now,
Yes.
it's good to write it out like this because you can easily use this method to find both the LCM and the HCF. First of all, HCF, you only tick the one that the ones that divided all through. Did these two divide all through? These first two? No, it didn't divide all through, so we don't tick it. These 3, did it divide all through?
This 3, yes.
Are you sure it divided all?
No.
It didn't divide all through. Did the 5 divide all through?
5 did, yes.
So you mark it. The ones that divided all through, you multiply them out. Assuming there was another 3 that divided all through, you also mark it, and then you say 5 times 3. But it was only 5 that divided all through. So the HCF will be 5. Only the one that divided all through, because that's the common one. HCF is 5. Then the LCM is everything. LCM is you multiply out everything. Do you know? LCM will be 2 times 3 times 5, which is what?
Which is
30. All right, let's see some of the other questions you did. Okay. Can we see this one? Can we do both the LCM and the HCF of this C? So tell me what to do. This number 2C.
You divide.
Okay.
So
let's
you
do 18.
The line thing. Did you do the line thing?
Okay. Let's do this one. 18 and 24. Let's start.
So you divide both by 2.
Okay. Let's start with 2. Let's start with 2. All right.
Should I find both the HCF and the LCM?
Yes. So, be telling me.
Divide both by 2.
Okay. So I'm going at 18 divided by 2 will give what?
9.
9. 24 divided by 2?
12.
12. All right. What can I use to divide again?
3.
Can you use the lowest?
2.
2 can divide. Okay. 9 divided by
Okay,
2.
that'll be 9.
9 because you cannot divide. So you can't divide without a remainder, so you bring it down. 12 divided by 2.
6.
6, okay. What can I use to divide again?
2.
2. Because 6 can, anything that can divide at least 1, you use it. 9 divided by 2.
9.
9. 6 divided by 2. 3.
3.
Okay. What can I use to divide again? All right. 3. Okay, let me use a line here. All right, let's go. 9 divided by 3. 3, isn't it?
Yes.
And 3 divided by 3 is 1, isn't it?
Yes.
What can I use to divide again?
3.
3. 3 divided by, this 3 divided by 3, 1, and you also bring this one down. So for LCM, you multiply everything, isn't it?
Yes.
And for HCF, let's take the ones that divided all through, first of all. Let's take the ones that divided all through, first of all. These 2 divide all through, these first 2.
Yes.
We take it. This second 2, did it divide all through?
No.
No. This third 2.
No.
This 3. First 3.
Yes.
This last 3.
No.
No, yes.
No.
No, because it didn't 1 did not divide 3. So we are, let me take this thing further a bit so it doesn't look like I'm actually multiplying. I was just saying you tick, you know. So this couldn't divide all through, this couldn't divide all through, this couldn't divide, this divided all through, this couldn't divide all through. So for LCM, you know, you multiply out everything. That is everything 2, 2, 2, 3, 3. That is 2 times 2 times 2 times 3 times 3, isn't it?
Yes.
What would that give you? You can even say 2 raised to the power 3. That's 2 in 3 places. That's what 2, you know, 2 raised to the power 3 means 2 in 3 places, isn't it?
Yes.
2 raised.
That would be 8 times 9, and that would be 72.
Excellent. Beautiful. So times 3 raised to the power 2. Or 8 times 2 raised to the power 3 is 8 times 9 is 72. That's for LCM. What about HCF?
HCF is
You only
HCF equals to
only the ones that multiply all,
times 3. That would be 6.
only the ones we ticked that multiplied all through. Only these 2 and these 3. So 2 times 3, that's 6. Okay. Beautiful. Can you do this number? How do you answer this one? Are you ready?
Okay.
Tell me. 60 is already giving us 2 raised to the power 2 times 3 times 5. Do you even know how we came about this?
Yeah.
And how we
Yes.
came about this? We call it prime factorization. Sometimes you may be asked to do that. Let me even write it down before,
Okay.
assuming you didn't know. They may ask you, this is how it is done. Find the prime factors of 60 and also of 84. Not the common one, let's just do them separately. Okay, of 60, then of 84. You said you know how to do it.
I'm not sure.
It's actually easy. You start dividing 60, starting with the smallest prime number.
Yes, I remember.
By the way, what are prime numbers? I think we need to talk about what are prime numbers. Tell me first of all, what are...
Prime numbers are numbers that can only be divided by one and themselves.
All right, that's cool. Prime numbers can only divide one and itself without a remainder.
Yes.
Prime numbers are numbers that can only divide one and itself without a remainder. So it means its factors are what?
His factors are 1.
And itself.
Yes, 1 and itself.
Therefore, its factors are 1 and itself. Are 1 and itself. So it has how many factors?
It has it has two five it has 2 factors.
Only 2 factors. 1 and itself. So what are the prime numbers? Let's list the prime numbers starting from between 1 and 20. Between 0 and 20. That can only divide itself and 1 without the remainder. So let's see prime numbers between 0 and 20. Give me the prime number between 0 and 20.
2, 3,
0 and
5,
20. Okay. You said 2,
5, 7,
3, 5, 7,
11,
11,
13,
13,
17, and 19.
and 19. That's
And
good.
that's all.
And that's all. You are right. And 19. Why is 15 not a prime factor? Why is 15 not a prime factor?
You can divide it by 5.
Because 15 can divide 1, 15 can divide 3, 15 can divide 5, and 15 can divide itself. So since it can divide 3 and 5 apart from itself, it is not a prime factor, isn't it?
Yes.
All right. So sometimes they may give you this and ask you to find its we call that prime factorization. Prime factorization. Prime factorization. So let's do that first of all. Prime factorization. Okay, for instance, if you are given 60, let me tell you, let me remind you of how to do it. Just start dividing it with its prime numbers. Are you ready? Are you ready? Start dividing it with prime numbers. Start the lowest. 60. What's the lowest? 2. 60 divided by 2 is 30. 30 divided by 2.
3.
You can pick 2 again. 30 divided by 2 is 15. Am I right? What can you pick? What can you pick again? What can you pick again?
3.
Okay, 3. 15 divided by 3 is 5. What can you pick again?
5.
5 again. 5 divided by 5 is 1. That's why 60 is equal to 2 times all these things, multiply them out, multiply them out, multiply them out. That's 2 times 2 times 2 times 3. 2 times 2 times 2 times 3 times 5. Okay. 2 times 2 times 3 times 5, or 2 raised to the power 2 times 3 times 5. That's how they came about this. Okay. Can you do that can you do that of 84? Do that of 84. Let's go. 2, that would be 84 divided by 2, that's 42, right? 2 again, that's what?
21.
21, okay, sorry. That's 21. Okay, what can you use again?
You can also use 7.
No, you shouldn't jump anyone. Make sure you exhaust all the lowest
5,
prime factors.
3.
21 divided by 3 is 7, and then what can you now? 7, that's 1. So that means, therefore 60 is this, therefore 84 is what? 2 times, multiply out everything, all the numbers, 2 times 2 times 3 times 7.
3 times 7.
Or you can say 2 raised to the power 2 times 3 times 7, isn't it?
Yes.
Beautiful. Times 3 times 7. Good. If you have found this, how will you use it to find a... Look at the question now. Read it out. I'm underlining it.
Okay.
You're giving 60 as 2 raised to the power 2 times 3 times 5 in red. You're giving 84 as 2 raised to the power 2 times 3 times 7 in green. So you're asked to find the LCM. How will you use that to find the LCM? Tell me. Do you know how to do it?
Yes.
Okay, what do you do?
You pick 2.
Okay, for
2
let's look at LCM.
2
We picked 2. I think 2 raised to the power 2.
2 raised to the power 2
In fact, you always pick. Okay, then what else do we pick?
3
3
and 5.
And 5?
Or 5 didn't go in. I don't think 5 could go in.
You don't think, or you are sure?
I'm sure. I think I'm sure.
Okay, I'm just listening to you. What else do we pick?
And
that's SCM or not HCF, so be careful of what you are trying to tell me.
okay. That's one.
Only 2 and 3?
No, 2, 3, and 5.
You're not sure. Okay, you're not sure. All right. Okay, can I tell you something? Let me, since you have an idea, let me tell you, let's start with HCF. HCF is easy. If you're asked to find the HCF, are you listening?
Yes.
You pick the ones that you have in both of them. The same thing you have in both of them. We have 2 raised to the power 3. Are you looking at what I'm talking about?
Yes.
We have 2 raised to the power 2 for 60, and we also have it for 84. So we will have 2 raised to the power 2. Did you hear that?
Yes.
We have 3 in 60. We also have 3 in 484. So we add the 3. 5 is in 60, but 5 is not in 84. So that's all for HCF. You know, HCF will be the ones that are common. So what would that give? 2 raised to the power 2 times 3. As 4 times 3, which is 12. Okay?
Yes.
Okay, I've shown you how to do the HCF. How do you do the LCM? HCF is the ones that are common for both. You know.
Yes.
So how do you do the LCM?
The LCM is the lowest common one. So that means that'll be that would be 3 and 3 because 2 times should I just put 2?
Let me tell you how to do it. Pay attention. Are you ready?
Yes.
Now, pick all the factors, all the prime factors you have here. All of them. What did I say?
All of them.
Good. All of them. Now, you are going to pick all of them. But when you pick a particular one that is already in the other one, don't repeat it. This is what I'm saying. Pick all of them. Let me start all over again and show you. Watch me. Oh, I'm going to pick all of them. I'm going to pick all of them. What are the factors we have in? Let's even see this.
2.
We have 2, 2, 3, and 5
3, 5
for 60.
Yes.
And we have 2, 2, 3, and 7 for 84. So we are picking all of them. But whatever we have picked in the first one, we're not going to repeat it in the second one. But we must write out everything. So
Yes.
I already have 2 times 2. That means there's 2 here, there's 2 here, there's 2 here, there's 2 here. So I don't have to write the 2 and 2 again in the other one, isn't it?
Yes.
Then times 3, there's 3 here, 3 here, there's also 3. I don't have to write the 3 there again. Then times 5, there's 5 here, there's no 5 here, but I must pick everything. Then times 7. Can you see it?
Yeah. Yes, I can.
So what does that give? 2 times 2 is 4.
2 times 2, 4.
4 times 3, 12.
12.
12 times 5, 60.
16.
60 times 7 is 420. So the LCM is 420. You know what I will do? Let me give you more examples. Let me give you more examples so that you will understand this better. Assuming you have a number, I have a number Q. Let's take another example. Are you ready?
Yes.
We have a number Q whose factors are 2 times 2 times 2 times 3 times 5 times 5. You can even get what the number is. Then we have another number P. We have another number P whose factors are you ready? Make sure you're paying attention now. 2 times 2 times 3 times 3 times 7 times okay, times 7. Let's even know what these numbers are. I might decide to even get what these numbers are. It is not the problem. So what's it? By the way, this one is the same thing as. Are you listening?
Yes, I am.
Beautiful, 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 beautiful. Then you are asked to find. Watch it. Oh, it's very interesting. Find A, LCM, and then B, HCF. So for LCM,
Times.
okay,
Times both first.
okay,
Or I'll just 2
2 times 2.
times 2 times 2
Mhm.
times 3.
No, you are not done. You must get the highest.
2 times 2
Times 2.
times 3
times 3
times 3
times 3.
times 3.
No.
No, sorry, no. Wait. Times.
Mm-hmm.
Okay, times. I can't see your mouse moving.
No, just tell me.
Okay, times 5,
Mm-hmm.
and then times 7.
No, you've not finished everything. You see, when you are writing out.
Times 5.
Mm-hmm.
Then times 7.
10 times 7. When you are writing out these things, make sure the highest number of 2 must all be written. For instance, this one has how many 2's? This is 2 raised to the power 3, is it not?
Yes.
Before 3 raised to the power 3 is 3 raised to the power 2. 2 raised to the power 3 means there are 1, 2, 3 2's. So that's why I wrote 2 raised to the power 3. You understand?
Yes.
Then times 3 raised to the power how many 3's? Okay, that's only 1 3. This one has only 1 3. So that's just 3 raised to the power 1. Then times what again? Times 5 raised to the power 2, is it not?
Yes.
There are 2 5's. Then when we come to this one is 2 raised to the power what? How many? 1 2 2
1
2 raised to the power 2. Then times 3 raised to the power how many? 2.
2.
Then times 7. So when you are doing this, when you are picking any number, write out the highest of them. 2 has how many places? How many? 3. So you must write out all the one that is more. Did you see that? For LCM.
Yes.
When you come to 3, you go to the biggest one. The biggest one has 2. So we take the biggest one. The biggest one that has 2. Just like we took the biggest one that has 3. For when we're writing out 2's, we pick the biggest one that has 3. When we're writing out 3's, we pick the biggest one that has 2 places. Then we come to 5. We take the biggest one that has 2, and then 7. So what does this give? Let's get the answer. 2 times 2, that's 8. Times 3 times 2, that's 9. Times 5 times 2, that's 25. Times 7. You can now get the answer, okay?
Okay.
Okay, first of all, let's get the HCF. How did I say you should get the HCF? It must be something you have up and you have down. So when it comes to HCF, you pick the lowest one. I hope you remember this. Okay, what's the HCF?
Okay, and that'll be 2.
That's 2.
Because it's the lowest one.
So 2 times 2, only in 2 places.
Yes.
The 2 that appeared only in 2 places is the one we are taking.
Yeah.
Then when we come to 3,
And
3 appeared in 1 place and appeared in 2 places.
3
in
times 3
in 2 places or in 1 place?
in 1 place.
1 place,
No,
which is
in
lower.
1 place, yes, in
1 place, which is
It's
lower.
lower.
Okay, can we pick 5?
No.
We can't pick 5.
No.
We can't pick 5 because 5
Yes.
is in up, but we don't have 5 down. Can you see it?
Yes.
So can we pick 7?
No.
No. Also no, because 7 is in
Also
down but it's not in up. 7 is in down but it's not in up. So it's only 2 times 2 times 3, which is what? That's 4 times 3, that's 12. The HCF will be 12. Please take note of what I just did. By the way, 8 times 9 is 72. Let me even just work out the LCM very quickly. LCM will be 8 times 9, 72 times 25 times, that's a large number, times 7. That's 12,600. That's a very large number. 12,600. 12,600. I hope this is clear.
Yes.
Okay, you're going to practice some more. All right, so for these practice questions, let me know what did you get for A, 1A, the LCM?
One in the LCM, I got 900.
LCM, okay, what did you do?
I did all and now added
No, let me be telling me. I'm sure I'm working it out on the screen. Just tell me what you did for A, number 1A. Yeah.
R equals.
What are the things you picked? First of all,
Okay.
tell me.
2.
You picked 2. There's 2 in here.
2, 2.
2 times 2 because the highest of 2 is in 2 places.
Times 3 times 3.
There are 3 3s. The highest of 3 is 3 places. Yes.
Times 5 times 5.
The highest of 5 is 2 places. You always pick the highest for LCM.
Yeah.
Is that all?
No, that's not all. Yes, that's all.
No.
That's all.
For LCM, you have to pick everything. You have to also pick 7 and 11 times 7
times 7
and then times 11.
times 11.
For LCM, you are picking everything, but you pick the highest of them. The highest of 2 is in 2 places, so you picked 2 in 2 places. The highest of 3 is in 3 places, in 2 places, so you picked 3 in 2 places. The highest of 5 is in 2 places, so you picked 5 in 2 places. Then there's 7 and there's 11. So what would that give you? This will be equal to 8 times 9 times 8 times 9 times that. What does that give? Okay, let me just work it out. 8 times 9 times 25. 8 times 9 times 25 times 77. That's 138,600. It's a large number. 138,600. It's a large number. Okay. Did you 138,600? Did you get it? Okay, when we come to HCF, what do we do? First of all, did you understand what I did?
HCF. Yes.
HCF, let's get that of HCF. HCF, you pick.
Okay. HCF. I did 3.
You pick what you have in all of them, common in all of them.
Yes.
There's 3 here.
Yes.
There's 3 here.
3.
There's 3 here. So we pick 3.
And 5.
There's 5 here.
5.
There's 1 5 here. There's 1 5 here. If there were 2 5s in all of them, then you would have picked 2 5 5s. You understand?
Yes.
So I think it's only 3 and 5.
That'll be, and I got 15.
15. So the SCF is 15. That's correct. Okay. So this one, use the long method. That's 75, 150, and 50. Did you use the shorter method, division? I think it's easier.
Yes, I did the shorter method.
Okay, so that will be, let's just pick it. 2, can 2 go? Yeah, 2 can go. At least one can divide at least one of them. 75 cannot divide, so you bring it down. This one will be 150 divided by 2 is 75. 50 divided by 2 is 25.
Yes.
What can go? I think 3 can go. Yes, 3 can go.
Yes.
This one will be 25. This one will be 25. 25 cannot divide, so we bring down 25. I think 5 can go.
I used
This
5
by 5, 5, 5. And then 5 can go again. That will be 1, 1, 1. So what's the LCM?
The LCM.
You pick everything.
The LCM for my answer it was 150.
That's correct,
The
which is
HCF
2
was
times
25.
3 times 5 times 5. 2 times 3 times 5 times 5. Then that's 150. Then the HCF, only the ones that multiplied all through. Where are they?
There were
only the 5s. Only this 5 and this 5.
5
This one
and
did not.
5.
This one did not. So HCF is just 5 times 5, which is 25.
25.
I think that's clear. If
Yes.
of course it's the same principle. If they ask you find the product of,
Sir, can you scroll up a little bit?
okay, is there something you want to write?
Yes, for those I missed.
Okay. But do you have any question, or is it clear?
It is clear.
All right.
You can scroll down now.
Okay, that's correct. You've done very well. Like, for supposing you ask find 150 as a product of his, or write 150 as a product of his prime factors, or something like this. If you ask write 150 as a product of its prime factors. Product of what?
Of 150 as
A product of its
of
prime
5.
factors. We just divide it all through by, let's start with the smallest. 150 divided by 2 will give you 75, is it not?
Yes.
2 cannot divide, let's use 3. 75 divided by 3 will give you 25. Not 3 again cannot divide 2, so let's use 5. 5 divided by 25 with 5, then 5 divided by this with 1. So what's the answer? That means 150 is equal to what?
150 is equals to
2
2
times
times 3
times
times
5
5
times
times
5.
5.
If you like, you can say 2 times 3 times 5 raised to the power 2 is the same thing, isn't it?
Yes.
That's just it. Isn't it cool?
Yeah.
Yeah, because this one is 1. Then that's fine.
Yes.
All right. All right, let's see these exercises. Number 1, write 360 as a product of its prime factors. Number 2, given that 18,000 is equal to 2 raised to the power a, let me zoom it in so that we can see it better. Number 1 is write 360 as a product of its prime factors. Number 2 is given that 18,000 is equal to 2 raised to the power a times 3 raised to the power b times 5 raised to the power c. Find the values of a, b, and c. Number 3, find the LCM and HCF of 36 and 54. Number 4, work out 6 times 12 as the product of prime factors. Give your answer in index form, like something raised to the power something raised to the power something. Number 5, a is equal to 2 raised to the power 2 times 3 times 5, and b is equal to 3 times 5 raised to the power 2. Find the LCM and HCF of a and b. Now section B. $4116, 4,116 is equal to 2 raised to the power 2 times 3 times 7 raised to the power 3. Write down the lowest integer by which 4,116 needs to be multiplied to make a square number. and then write 576 as a product of primes. Hence, find square root of 576. Write 1728 as a product of primes. Hence, find the cube root of 1728. And of course, checking out the video on basic numbers, multiples, factors, and prime numbers will help to answer the questions in section B. All right, that should be fine.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.